All right. Well, this video is meant to help you understand how to work with matrices. Chapter 8 is all about matrices. So matrices are basically a way to organize information. They're organized in rows and columns. So realize when we're looking at these two matrices here at the right, the top matrice we call matrice A. You'll notice the squared off brackets. That's the correct symbol for a matrice or a matrix. Again, it's got three rows. Rows work their way from left to right. So if you're looking at matrices, again, 512 would be considered the first row from left to right. Negative 310 would be considered the second row, and pi x the third row. Then we also have two columns. Columns are top to bottom or vertically. So again, 5 negative 3 pi would be column 1. Column 2 would be 12, 10, x. And when we write out rows by columns, we call those the dimensions of a matrix. So over here at the right where it says example question, we see it says find the dimensions of matrix A. Well, again, we said there are three rows, so we would say 3 by, and then there are two columns, 2. Each piece of a matrix, so the 5 on its own or the negative 3 on its own, you'll notice they can be irrational, negative. You can technically have fractions. You can have whole algebraic expressions in as an element. Each piece is called an element of a matrix, or it's sometimes called an entry of a matrix. It can basically mean the same thing. When we refer to which element or which row column we're talking about, you'll notice the notation over here at the right. They use a lowercase a because it was a part of or an element in matrix A. And then you'll notice a little subscript. It says 2, 1. Now that looks like a 21, but it really refers to row 2, column 1. So if we were looking at that, we would go to row 2, column 1. We would be looking at this negative 3 right here. And basically when they say what is the element A sub 2, 1, that element is negative 3. Again, we refer to each element in the matrix by that notation. Normally also, by the way, you may see those dimensions written in the lower right corner. Oftentimes we'll write those down here and just say this matrix is a 3 by 2. It is fairly important that we find the dimensions of a matrix often. That's going to limit what we can do with a matrix or how we refer to that matrix. So looking down here at the bottom, again, this would have been 2 rows, 2 columns. Notice they are all zeros, which kind of fun fact means this is what's called a zero matrix. So we can call it that down here at the bottom. It's also what we call a square matrix, and that is very important. We can do a lot of different things with square matrices. So again, this being 2 rows and 2 columns, the dimensions of matrix B would be a 2 by 2. Again, depending on those dimensions, that can tell us what we can do with a matrix. So, first thing we can talk about is equality. It's a fairly simple idea. If two matrices are set equal to each other, and they have the same dimensions, obviously they need to have the same dimensions to be equal to each other, then they are both 3 by 2 matrices, you'll notice. And each element within each matrix should be corresponding-wise equivalent. So notice row 1, column 1 was a 1 here, row 1, column 1 was a 1 there. Row 2, column 1 is 0.6 repeating, which is equivalent to, again, that 2/3 over there at the right. You'll notice each one, 2.5 and 5 halves, the square root of 9 and 3. Each element essentially is equivalent to its corresponding element, which means when we want to find x down here at the bottom, we're going to look for which element has an x in it. So we've got x plus 7 in row 3, column 2. We also have a 10 in row 3, column 2. And if x plus 7 were equal to 10, then x must be equal to, by subtraction, 3, and we have our answer. Using that same corresponding elements idea, we can perform a couple of different operations, adding and subtracting. If you are adding two matrices, again, with equal dimensions, it's very important that they have equal dimensions, you're just going to add the corresponding elements. So taking a look at these 2 by 2 matrices up here, again, I've got a 2 by 2 matrix on the left, added to another 2 by 2 matrix, which results in a 2 by 2 matrix. We're going to add row 1, column 1 to row 1, column 1, and end up with row 1, column 1, 1 plus 5 being 6. Same idea, row 1, column 2, 2 plus 6 would end up being 8. And in the same way, we've got this 3 and 7 makes 10, and finally 4 and 8 makes 12 in the lower right corner there. The same thing works for subtraction. Just remember to subtract. So again, we're saying that this 3 in row 2, column 1, minus this 7 would end up being this negative 4. And it just so happens with the numbers that we used, you get negative 4 in each element or each entry of that resulting matrix. You can also multiply by what we call a scalar. Remember, a scalar number is just, very simply, an integer or just a single digit number. Could be, I guess, could be decimal, could be a fraction. But a scalar multiple, again, is just multiplying a matrix by a number, by a constant, essentially. And then to do that, it's almost like the distributive property. We're just going to take that 9 over here at the left, and we're going to multiply it by 1, by 2, by 3, by 4. Again, 9 times 1 being 9, 9 times 2 being 18, and essentially throughout, just multiply everything in the matrix by a 9. Again, you can multiply by any number and just do the distributive property. Realize that there is no such thing as matrix division. So if you wanted to divide by a number, you would actually have to multiply by a reciprocal instead. It's not that we can't divide 1 and not 2 and 3 and 4. You just can't divide the whole matrix by a number. So if we wanted to multiply by 1/9, let's say, again, we could do that to make it a 1/9, 2/9, 3/9, 4/9. But again, your calculator would not let you divide by 9. Again, matrix division is just not something that's possible. Speaking of your calculator, though, you can perform these operations on your calculator. So give me a second here. We'll let that calculator start up. Basically, all you need to do is go into the matrix menu, and we can enter matrices into our calculator. It's a fairly simple process, and we can make that kind of thing happen. So let me bring that onto the screen here. So I'm going to go large screen there, and just clear off what we have here. What you do is you press second up here in the upper left corner on your TI calculator, and right above the x to the negative 1 button, about 3 buttons below second, you'll notice matrix is an option here. It's going to give you 3 menus. The names menu is where we'll pick our matrices. We'll do that in a little bit. The math menu is where we can do a lot of different things to our matrices, including things like transpose, which switches your rows and columns. And then finally, the edit menu is where we're going to put in our matrices. So again, I'm going to edit this. I'm going to make it fairly simple. Let's just do a 2 by 2. It's going to make you put those dimensions in at the top every time. Then I'm going to put in, fairly simple numbers, 1, 2, 3, and 4, just like that. Again, we can go back to our menu, so second matrix, over to edit, and we can put in matrix B. And again, I'm going to make that a 2 by 2, and we're going to put in, again, fairly simple numbers. Let's go backwards this time, 9, 8, 7, and 6. About. Okay. So that now, again, I can go back to my main screen. If I want to add those 2 matrices, I'm going to press second matrix, number 1. That gets me matrix A. Notice it shows up again with those square brackets. Anytime we write a matrix, we're writing it with square brackets around it. Plus second matrix, second matrix here, B. And if I add those 2 together, there's my resulting matrix. Notice you're not going to see what the actual matrices were. To figure that out, you either have to go into your matrix menu, or we would just type in our matrix alone to remind ourselves what was inside of our matrix. But that's essentially what your matrix is going to look like in classic mode on your calculator. Again, they'll look a little more realistic or a little more like you would write on your paper if you're in math print mode. So it might look a little different on your screen. Again, if we want to multiply by a scalar, let's say something like 2/3. I would just take 2/3, 2 divided by 3. I like putting them in parentheses, although not completely required. I missed the division button there. There we go. And then we can multiply that by second matrix. Let's just multiply by matrix A. We'll hit enter. And you'll notice anything that comes up decimal-wise is going to look a little bit long. Remember, you can always hit that arrow to fraction button. So we can do math. That first option. That'll make it look a little more realistic there. Again, there are 4 options. If things do go off the screen like that, just tap to the right, and it should let you scroll over and see what those numbers were. Right. And there's some basics of how you can use your calculator to enter matrices. A couple more examples for you very quickly. Tell you what, take a second, go ahead and pause the video now if you'd like to, and you can do these examples. I'll leave a little bit of time gap here, and if you want to try those, go right ahead. And then we'll come back and we'll talk about one more way we can actually use matrices. All right, and we are back. Up top, we've got a subtraction problem over here on the left. So you'll notice again, I just took the corresponding elements, -10 minus 2, made for -12. And again, all the different corresponding elements making our answers on in the matrix there. Over at the right, we had a little scalar multiple, so multiplying by -4. So notice all the negative numbers became positive, the positive number became negative. But again, 10 times 4, 1 times 4, 5 times 4, 6 times 4, getting us our answer there. Notice again, 2 by 2 minus, or 2 by 2 multiplied by a scalar, same thing 2 by 2 with addition. We're getting 2 by 2 answers as well. Again, the corresponding elements down here at the left. Again, because there were a lot of negative numbers, I went ahead and wrote it out so that I didn't lose track of where my negative numbers were. That's always an option. But don't forget to do your final resulting matrix as well down here at the bottom. And over at the right, we had a little bit of scalar multiples going on with a little bit of addition. So again, I went ahead and distributed my 2, distributed my 3, and then added corresponding elements such as 4 plus -30 made -26 over here at the right. Again, you just follow your order of operations and you'll be in good shape there. Finally, one way we can actually use these matrices is in real-world problems. Oops, sorry, I went a little too far there. So again, if we've got a music service here, it's got units and dollar values and albums, lots of stuff going on. Basically, we can organize our matrices. So you'll notice the 2016 numbers. We've got 3 different units. We've got 3 different dollar values. So I went ahead and organized in 3 rows and 2 columns. These would be our songs, our albums, and our music videos. And then across the top, we've got our our number units and our dollar values. Right? Same thing goes for the 2017 numbers, although I'm not sure quite why. Give me 1 second here. Not exactly sure why. All of a sudden that had an extra 7 in it, but that's okay. I'll come back to that. And now what we want to do is actually figure out, write a matrix that gives the total number of units streamed and total values for both years. Well, if we want the total, we basically want to add them up. So I'm going to take the matrix for 2016. I'm going to add it onto, right? Let's add that onto our matrix for 2017. And in the end, if we add the corresponding elements, here's what we end up with. Again, ending up now with the songs, our albums, and again our music videos. Right, our music videos down here. And again across the top, still organized in numbers and dollars. If we want to find the change in units typically means the difference. So again, that time we're going to take the change in units from 2017 minus the number of units in 2016, and in the end, again, do that subtraction. You'll notice that's what you'll end up getting, and everything works out nicely. I hope that helps you with matrices. Good luck. Make sure you do your homework and ask your teacher if you have any questions. Have a great day.